In the next few lectures, we shall look at resistive force and moment analysis for simply supported beams. Here, we shall consider a central point load on the beam. Let's have a simply supported beam with a pin or hinge support at the left end and a roller support at the right end. Let's label the ends as A and B and the midpoint as C. Let's show a central point load denoted by P kilonewtons. Let's mark the lengths of the parts AC and CB as half times L meters. We denote the left end A with pin support as the reference end and mark an arrow directed towards the right, labeling it as X. We also drop down the projections from the key points, draw the zero datum lines, and label them as shear force diagram and bending moment diagram respectively. Now, before finding the unknown resistive forces and moments within a beam's cross-section, it is first necessary to estimate the value of the reaction forces and reactive moments, if any, considering the entire beam in static equilibrium. Without going into the application of the equilibrium equations for the whole beam, we directly write the value of each reaction force at the supports as P over 2 kilonewtons, since the loading is symmetric with respect to the beam by mere investigation. Let's now write the equations for region AC for which x is greater than or equal to 0 and less than or equal to 1/2 L. The shear force at x equals plus P over 2 kilonewtons, which is a constant value. For region CB for which x is greater than or equal to 1/2 L and less than or equal to L, the shear force at x equals plus P over 2 minus P, which gives minus P over 2 kilonewtons and is also a constant value. Now bending moment at x for region AC equals plus P over 2 times x, which is a linear equation in terms of x, and for region CB, M at x equals plus P over 2 times x minus P times x minus 1/2 L, which also happens to be linear. Now we apply the limits for the lengths of the respective regions for calculating the shear force and bending moment values and plot the same accordingly in the respective diagrams. The maximum shear force is found to be 1/2 P kilonewtons spread across half the beam lengths and changing direction, and the maximum bending moment is found to be P times L over 4 located at the center of the beam. In the next lecture, we shall discuss the case of an eccentric or unsymmetric point load acting on the simply supported beam.